Now, if you see, for example, if you look at this formula, as I've told you, you have to remember the number of bonds formed by each element. So if you look at this formula, it's C2H6O. See, carbon has a 4 bonds. Hydrogen has 1 bond. And oxygen has 2 bonds. So whenever I make a structure of this formula, I have to make sure that every carbon which is drawn have a 4 bonds, every hydrogen has a 1 bond, and every oxygen has a 2 bonds. Is this understandable? So on the basis of that, if you try, we will get one this displayed formula and the other one this displayed formula. But if you see over here, see, they both have a same molecular formula, but if you look at the structure or at the displayed formula, they are completely different from each other, isn't it? Is this understandable?
Yes, sir.
Yes, Mustafa. So these two have different structures but the same formula, so that's why they are called isomers. So remember, isomers are the compounds who have a same molecular formula but different structure, and different structure means they have a different structural formula, and when we go for this displayed formula as well, we will find their displayed formula is different as well. So these kind of compounds are called isomers. Now, if you see over here, what is the difference between these three structures? Can anyone identify?
Sir, no difference.
No difference, because see, this is the straight chain and that straight chain is bent over here and bent over here. There is a no branch structure. Assalamu alaikum, Manahil. So there is no branch structure. So these three are the same thing. So the important thing is that to remember is, if this is the structure, this is a straight chain. If I make it this thing, so tell me, is it a straight chain or a branch structure?
Branch.
No, it is also a straight chain. For a branch structure, it is the condition that a carbon must have a at least bonded to 3 more carbons. So think, look at this structure. Is there any carbon which is bonded to 3 carbons? See the bonds around each carbon.
No, sir.
There is no carbon over here which is bonded to 3 carbons, right? So it means it is also a branch structure which is drawn in the form of a bent, or in the, or it's coiled only, but it's a unbranched, it's a straight chain. Is this understandable? So all of them are a straight chain. Okay. So it means they have a same structure. Now let's have a look. For example, if I have a molecular formula of C5H12, how I can make the structure? Just try to understand this key concept. If you will get this key concept, it will be easier for you to make the isomer structures of the isomer. So 5 carbons, what I did, the first isomer I will draw have a all 5 carbon atoms in a chain, in a straight chain, no branch. And then what I do, I will put the hydrogens around. Okay, I'll put the hydrogens around, the number of bonds which are less, I'll put the hydrogen around. So this is the one isomer, isomer number 1. Now what I do for the second isomer, 1, 2, 3, 4. Instead of 4 carbons, I put the 5 carbons. Oh, sorry, instead of 5 carbons, I put the 4 carbons in a straight chain. Then on the second carbon, I made a 1 carbon like this. So see, this second carbon has now 3 carbons bonded to it. So it becomes a, so this is a branch structure. The structure gets changed because now there are 4 carbon atoms in the straight chain and 1 carbon atom comes in the branch. And here the structure is different from the right one because all the 5 carbon atoms are in the branch. Oh, sorry, are in the straight chain. So see, these two becomes isomers of each other. Now, how can I make another isomer from it? See, there are 4 carbon atoms in a straight chain and 1 in a branch. So what I do, I'll keep the 3 carbon atoms in the straight chain and then move 2 carbon atoms, one above and one below, to the middle one. So another branch structure is formed. If you see, this structure is different than the rest of the two. So it shows that there are 3 isomers. Is this understandable? And if you now, yeah, if you look at their molecular formula in each of the case, see C5H12. So here there are 5 carbon and 12 hydrogens. Here we have a 5 hydrogen, 5 carbon and 12 hydrogen, and here we have a 5 carbon and 12 hydrogen. Is this understandable to all of you?
Yes, sir.
Yes, sir.
Okay. So let's move to the isomerism. So isomerism is a phenomena which is shown by a compound having same molecular formula but different structural formula. So and the isomers are the compounds. So see, isomerism, a phenomenon, isomers, compounds. And those compounds having a same molecular formula but different structural formula or different structure are called isomers. So we have a molecular formula C5H12. Now have a look over here. We have studied these 3 structures over here. See how we will make the isomers. In first case, I keep the 5 carbon atoms in a straight chain like this. Then see how many bonds are left for each carbon atom. I put that number of hydrogens bonded to that carbon atom. I will get the same this formula. So that is the one isomer. Then for second isomer, I'll keep 4 carbon atoms in a straight chain and 1 carbon atom in the branch. Remember, branch doesn't start from the first or the last carbon. It always starts from branch is always placed to the from the carbons which are in the middle of the chain, not the terminal ones. If instead this, if I'll do this, for example, then it's not branch. It is actually same as this one. Okay. So one branch has been placed to make one isomer. Now, after this, what I did, see, I keep 3 carbon atoms in a straight chain, put 1 carbon atom and the second carbon atom, both 2 branches on the middle carbon atom. So see, with the C5H12 molecular formula, I got 3 isomers. Is this clear to all of you?
Yes, sir.
Now, have a look over here. It's C4H10. So see how I'll make the the isomers of C4H10. The first isomer, 1, 2, 3, 4. 4 carbon atoms. The first one and the fourth carbon atom has a 1 hydrogen. So I'll put 1 bond. So I'll put 3 hydrogens on both of them. Then the left behind has 2 hydrogens because they have a 2 bond. Now, if you count the number of hydrogens, you will get exactly the same number of hydrogen which are here. Now, how I'll make the another isomer? 1, 2, 3. Make the 3 carbons in a chain. The fourth carbon has a branch. Branch is always start from the carbon which is in the middle, which is not at the ends. So this carbon has only 1 bond of 1 hydrogen. This carbon has a 1 bond, so it will bond with 3 more hydrogens. This carbon has a 1 bond, so it will bond with 3 more hydrogens. And this carbon also bonds with 3 more hydrogens. Now, if you see, this is the another isomer of C4H10. So C4H10 has only these 2 possibilities, these 2 isomers. Is this clear to all of you?
Yes, sir.
Now, let's move to the C3H8. See, only 3 carbon atoms. It's a 1 isomer. See, if you try to make the branch, you can't make the branch out of it. See, so that's why it has only 1 isomer. There will be no other possible structure for C3H8. Is this clear to all of you?
Sir, I didn't get this one.
See, how many different structures you can make from C3H8? Only this one, putting 3 carbon atom in a chain.
Yes.
Yes.
Can you make any other structure of C3H8?
No.
No, I can't make a branch, right? Because it's like this. So it is same as this one. As I have told you, the branch is only formed by the carbons which are in the middle of the chain, not at the terminals, right? So
Yes.
this cannot be done. So it has only 1 structure. So only 1 isomer exists. Okay.
Sir.
And sir, एक और कार्बन वहां से कहाँ गया?
Sorry.
एक और कार्बन ऊपर से कहाँ गया?
No, we are talking about the different compound. C4H10 has only two isomers, these two.
Okay sir, okay.
This is the different compound, okay?
Okay sir.
सर
Yes.
H4H C4H10 की ब्रांच बन सकती है ना उसमें?
Yes, here see, we have made the branch structure of C4H10 and this is the straight chain.
Okay.
There is a possibility for a branch. Now, if I keep the 3 carbon atoms in a chain and put the 4th carbon atom as like this, so it's a branch.
अच्छा सर ये दो ही आइसोमर्स है ना
Yeah, for
इसके?
C4H10, we got these two. For C3H8, only one. For C5H12, we have how many isomers we have? We have 3 isomers. Okay. Now,
Okay.
C5H10. Okay. So we will do the two things. If you recall, when we are doing the naming with the functional group, I have told you keep the functional group on carbon number 1 only, right? So that is its proper name is pent1-ene, which means that the double bond ene is on carbon number 1. Is this clear to all of you?
Yes sir.
Now, for example, if I shift the double bond instead over here, C over here, so see, it's not called pentene. I can call pentene this one, because if I'm not mentioning the position, it's understood that the functional group is on carbon number 1 only. Okay.
Yes sir.
Okay. The screen is freezed. Yeah. It's still freezing. But on the right, if you look at the structure, let me reshare it. Okay. So when I have put the double bond in the middle, see now starting from here, it's carbon number 2. So I cannot write it pentene. I have to write it pent2-ene, which means that the double bond is on carbon number 2. Is this understandable?
Yep.
So see the second isomer, because the position of the functional group is changed. Now, how can I make the third isomer? Okay, if I move it over here, it is again remains on the same position. See, if I do this, I put the double bond over here. Then see, starting from here, it's on carbon number 2. So these two are the same things. Whether you make the double bond on carbon 2 from the right or from the left, it's the same. Is this clear? Why it's freezing, I don't understand. It's again freezing, right? So see, due to a position of a double bond, it becomes 2-ene, right? So it's the isomer of this one. Now, how can I make a different possibilities? First, see, 5 carbon atoms, straight chain and a double bond on the first carbon. Now, 4 carbon atoms in a straight chain, double bond on the first carbon atom and make a branch. Keep the position of the double bond same and just put a branch. It will give me the third isomer. Then see, I can do this one, that for the same structure, I shift the position of the double bond. So the fourth isomer, see here what I did. If you see, if you get the concept, isomer, both are same, only the position of a double bond gets changed. So I will get the different isomer. These two, position of the double bond same, only the branch got over here instead of a straight chain, makes the isomer. Now, these two are same, only the position of the double bond changes from here. So see, is this understandable to all of you? So by changing the position of the functional group, or by, shifting, and or by making the branch structure instead of a straight chain, we will get the isomers. Okay, just give me a minute. Assalamu alaikum. हाँ जी, हेलो। वालेकुम अस्सलाम, कहाँ हैं आप? अल्लाह का शुक्र, मैं तो घर पे हूँ, क्लासें चल रही। हाँ, नोट्स ले आए? तो कब जाओगे? तो हसन तो मुझे कह रहा था वाजिद भाई आ रहे हैं मेरे पास लेने। भाई मुझे तो 100 वाली चाहिए थी, एक 50 वाली चाहिए थी। हाँ, और उसके अलावा 20-20 और 10-10 वाली भी अगर 2-3 मिल जाती, मतलब टोटल 20 और 10 की मिला के 3 अगर हो जाती। तो आप हसन के पास गए नहीं लेने? अच्छा, आप हसन के पास गए नहीं लेने? अच्छा, मेरी वाली भी बढ़ गई क्या? तो मेरी वाली भी आपने दे दी? चले खैर, आपका मसला नहीं हो तो मैं हसन की माँ। नहीं ठीक है, ओके। ओके, अल्लाह हाफिज, अल्लाह हाफिज। ओके, नहीं 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 नहीं, मुझे चाहिए। ओके, अल्लाह हाफिज। ओके, now we have a next structure C4H8. So if we go for a C4H8, see, the general formula is CnH2n. So we go for the same thing, straight chain and a double bond over here in the first carbon. Now what I did to make the another isomer, I shift the double bond position, right?
Middle.
And then what I can do, I cannot shift it to any other position. So I will make the straight chain a branch structure. That is the third possibility. So see, instead of keeping the 4 carbon atoms in a straight chain, I'll keep the 3 carbon atoms over here and put 1 carbon atom in the middle, making it a branch structure. So see, we will get 3 isomers of C4H8. Is this clear?
Yes, sir.
Yes, sir.
Okay.
Sir,
Yeah.
sir, इसका क्वेश्चन किस तरीके का आता है?
They will ask you, they will sometimes give you a one structure and ask you to draw the other one. Draw the other isomer. That's how they ask you. For example, examiner has given you this structure like this and told you to make one branch isomer of this one.
सर ब्रांच वाला भी बन सकते हैं और इसमें मिडिल कार्बन पे डबल
Yeah,
बॉन्ड लगे
it
भी बन
depends. If examiner asks you to draw another isomer of this one, so you can do any. But if the examiner asks you to draw the branch structure of this one, so you will do it like this. A double bond over here, 2 hydrogens, 3 hydrogens, 3 hydrogens, and see, we got the whole structure. Okay.
Yes, sir.
Okay. Now, C4H10O, it's an alcohol. So see, as I have told you when we were doing initially, to keep the functional group on the first carbon. That's what we call it butane one all. That one is referring that the all means OH and one over before OH means that OH is on carbon one. Is this clear? And we write butanol as well. So whether I write it butanol or butane one all, both mean same thing. Is this clear?
Yes, sir.
Now, what I do, I keep the straight chain and instead of carbon one, I put the OH on carbon number two, making it butane two all. Is this clear? So that is the second isomer. What I did, I keep the straight chain and shift the position of the functional group. Now what I do, if I keep the position over here instead of a straight chain, I make the branch chain. So that would be the third isomer. Then in the branch chain, instead of first carbon, I put the OH on the second carbon. See, that would be the fourth isomer. Is this understandable?
Yes, sir.
So do remember, first you have to keep the functional group on the first, then look for the positions for the functional group, that how many more positions can attain, the functional group can attain in the straight chain. When all the maximum positions of the functional group can attain are finished, then go for then put it on the again the first carbon atom and make the straight chain a branch chain. And then on branch chain, look for the maximum possibly positions for the functional group. That's how you can make the more number of isomers. Is this clear to all of you? Yes.
Yes, sir.
Now C3H8O, another alcohol. So as C, there are three carbon atoms, so I cannot go for a branch. So I can just shift the position. Instead of propane one all, I can make a propane two all, another isomer. So it has only two isomers. Is this clear to all of you?
Yes.
Okay. Now, after this, we have this structure. C4H8.
Sir,
Yes.
सर ऑर्गेनिक केमिस्ट्री कितनी मैक्सिमम मार्क्स की आती है पेपर में?
Sorry.
मैं कह रहा हूँ सर ऑर्गेनिक केमिस्ट्री मैक्सिमम
In
मार्क्स
paper
की
5, you
कितनी
will
आई
find
थी?
5 MCQs. And in the same way, think out of 80, you will get around 20 to 25 marks from organic.
ओके सर.
Okay. Now, C4H8O2. If you go for this general formula, you will find this, and it means that these are the carboxylic acid and esters both have this general formula. So both are isomers of each other. Okay. So carboxylic acids and esters both are isomers of each other. See, it's a carboxylic acid, right? There are 4 carbon atoms and one carbon has a C double bond O and OH group. So it's a carboxylic acid. Is this clear? And it's a straight chain carboxylic acid. So how to make this isomer? See what I did? I keep 3 carbon atoms in the chain and put the 1 carbon atom in the branch and make this carbon as a functional group. So see, these two becomes the isomers of each other because both have this molecular formula C4H8O2. Is this clear?
Yes, sir.
Okay. Now, see what happens over here. See, this is the important thing to understand over here. If we have a C double bond O, OH, which functional group is this?
Yes.
Carboxylic acid. Now think if C double bond O and after O there is a C in the continuity, then it is an ester. Okay. Then it becomes an
ester.
ester. C, it's a C double bond O, and after O, if it's an H like this, if you see, it's a carboxylic acid, but if we got over here a carbon chain, then it's an ester. Is this clear?
Yep, sir. Yes, sir.
To see how I'll make its more isomers. For example, look over here, there are 4 carbon atoms. I move this carbon atom from here and put it over here like this. See, is this understandable? And see, here I have discussed about the ester, that the oxygen along with the carbon chain containing C double bond O thing, that part of the ester is called alkanoate, whether it's on the right or on the left. For example, over here, O continued with the C double bond O and that with the carbon chain, that whole thing is considered as a alkanoate. The rest of the chain is called alkyl. Is this understandable?
Yes, sir.
Ji, sir.
When we name the ester's general name would be alkyl alkanoate. Okay. Now, so see, if you look over here, O with the C double bond O and this thing. So this becomes alkanoate. So how many carbons it has? 3 carbons, which makes it propanoate. And this one is alkyl and 1 carbon. So that's why the name becomes methyl propanoate. Is this understandable?
Yes, sir.
Okay. Now, what I do, I move one more carbon atom over here. So see, we have a 2 carbon atom over here, and with oxygen and C double bond O, there are 2 carbons. So it's ethanoate, it's ethyl. So name would be ethyl ethanoate. Is this clear?
Yes, sir. Clear.
Now, C double bond O, what I did, I move one more carbon atom over here. So over here, I got 3 carbon atoms and C double bond O, C double bond OH. So 1 carbon atom makes it methanoate and 3 carbon atoms makes it propyl. So it becomes propyl methanoate. Is this clear? And see, there is a one more ester which can be formed over here. That this one as 3 carbon atoms. The instead of the first one, this carbon which is in the middle bonds with the oxygen. See over here, bonds with the oxygen. So 1 carbon goes over here and 1 carbon goes over here. So see, these are the isomers of C4H8O2 molecular formula. 2 are carboxylic acid and 1, 2, 3, 4. 4 are esters. So in actual, there are 6 isomers of C4H8O2. Till here, is this clear to all of you?
Yes, sir.
Okay. Now C3H6O2. Again, general formula is same for carboxylic acid and esters. So see, well, how can I make a carboxylic acid? By keeping 3 carbon atoms and the first carbon atom with the OH, C double bond OH. Now, how can I make the isomer? I keep the 2 carbon atoms over here and third carbon atom over here. So it becomes ester. How can I make another isomer? By keeping just this, and over here, I got this too. So see, look over here. That is the carboxylic acid because C double bond O is bonded to OH as well. Now see, C double bond O is bonded to O and O is bonded to C, makes it ester. See, there are 3 carbon atoms. Out of these 3, 1 move over here and there are 2. Now in the next case, if you see, 1 more move here. So 2 and 1. So ethyl methanoate. And for 2 carbon atoms, the carboxylic acid and the ester, methyl methanoate and ethanoic acid. Okay, till here, is this clear to all of you? Yes, Khatija, Manahil, Mustafa,
Yes,
Ji,
sir.
sir.
Saad.
Yes, sir.
Okay, so you guys need to practice this isomers and we will do it in the past paper as well. Okay, now fossil fuels. So we know that there are 3 types of fossil fuels: coal, natural gas, crude oil, and petroleum. Compounds having carbon and hydrogen. In petroleum, okay, in natural gas, uh, Methane is a major constituent, but without methane, we have a ethane, propane, and butane over here. And in crude oil, it's a mixture of hydrocarbons. So it have a compounds having carbon and hydrogen in it. Okay. So we know that crude oil is a mixture of hydrocarbons. So as a mixture, it is not useful. But when we process it, we can obtain many products from it, which are very useful. Okay. The screen is stuck again. Now it's working. Okay. So that processing of petroleum is a separation of petroleum into useful fractions of fractional distillation by fractional distillation. Okay, we separate the fractions by fractional distillation. In fractional distillation of crude oil on a large scale, this is the process that we have already studied in experimental chemistry as well. So guys, just complete till here. Do this quickly. Then we will discuss further things. Okay. I will be back in a minute or two. By then complete this.
Sir,
Yes. Yes.
सर ये फ्रैक्शन इंडस्ट्रियल उसमें भी सेम ही होती है ना जैसे केमिस्ट्री में भी कराई थी फ्रैक्शन डिस्टिलेशन
Experimental chemistry, we studied 2 or 3 different fractional distillations of crude oil, fractional distillation of liquid air, and fractional distillation of ethanol and water. Like these notes, you will find them. Yes, are you guys done till here?
Yes, sir.
Okay, now, so we got different fractions from the crude oil, from the petroleum. So each fraction have a different properties, or you can say that each fraction, the properties gets changed. When we look at those fractions collecting from top to the bottom. So when we are moving from the fractionating column, from the fractionating tower, from top to the bottom, the properties that we get changed. At the top, obviously, there are very small molecules with a very low melting point. So the decrease in chain length. Okay, if we are going from bottom to the top, okay, when we move from the bottom to the top, the molecules getting smaller and smaller. At the bottom, the molecules are bigger. So decrease in chain length. The volatility gets higher. The molecules which are collecting at the top and even at the more top are more volatile, more easily, evaporate more readily. They can evaporate, have a lower boiling point. The boiling point gets lower and lower when we are going towards the top. And the lower viscosity means that the resistance in a flow, the which are at the bottom are more viscous, are more thick. So they experience some more with resistance when they flow. But the ones which are at the top have no or less resistance in a flow because their viscosity gets lower. Till here, is this clear to all of you? So after this, complete this quickly and then write the uses of the fractions over here. So over
Sir,
here,
can you please
yeah,
tell the viscosity again?
viscosity is the resistance in the flow of a liquid. If the liquid
Okay, sir.
flows quickly, then it's more viscous. It's less viscous. And if the liquid flow very slowly, it means it's more viscous. Okay.
Okay, sir.
Okay. Now complete this quickly. Yes, are you guys done till here?
Yes, sir.
Okay. Now we have a fractions and their uses. So you must remember these fractions and their uses as refinery gas is used in cooking, gasoline and petrol used in fuel used for fuels in the car, naphtha is the chemical feedstock. In chemical industries, it is needed as a raw material. Then kerosene, it's used in jet
Sir,
fuel.
आपकी screen नहीं आ रही.
Okay, screen is again hanged. Why is it so? Just a minute, please. After kerosene, we have a diesel oil. So see here we have. Okay, then after kerosene, it is used as a jet fuel. Then we have a diesel oil, which is used for a diesel engines as a fuel. Then we have a fuel oil, which is used in the ships and home heating systems. And after that, we have a lubricating oil, which is used as a lubricants, waxes, and polishes. and bitumen is used to make roads. Okay, complete till here. Okay, so we'll keep the class till here. And from here onwards, we will continue in our next class. Okay,
Okay, sir. Classes.
Hafiz
Classes are
and Hafiz. Okay, then take care, everyone. Allah Hafiz.